All right. So I figured that what I do with this session is talk about some of the things about Macaulay2 that are best demonstrated or talked about interactively as opposed to just like a rundown on a bunch of commands. So I've installed Macaulay2 on my computer, and this is what it looks like when I open it from terminal. And Macaulay2 functions as read, evaluate, print loop, which means that we have this input right here, and we can type things into it, and then it will evaluate what we type in, and then print out the result, and then it just keeps looping, waiting for us to type something, and then evaluate and spit out a response. That's the basic way to interact with Macaulay2. And Macaulay2 has been designed to make a lot of the things that we do in commutative algebra very easy. We're really first-class citizens in this programming language. So we can define a ring using notation that is familiar to the discipline, and we can take a quotient of this ring by some ideal. Oh, well, I should do R. And one thing that I think is worth pointing out while I'm right here is that if you now type in something like x plus y, it's going to use the most recently defined ring. It's going to assume that x and y come from the most recently defined ring. So you'll notice here that it said that x plus y is equal to y because when I quotient by x is equal to 0. And it also is especially helpful because it also prints out the type of y. So it's telling me that y's type is s. Y is an element of s. And if you aren't expecting this to happen, this might be the cause of some kind of error. So it's good to know that if you've defined multiple rings and you want to perform a calculation with any particular ring, you need to use the use command to reset the ring that you are currently operating in to the ring that you want to be operating in. And then now it shows us that this calculation is more what we would expect for back in the ring R. The other thing that is worth mentioning is that it's possible to define a function. And when you define a function, it will it'll do things locally. So the fact that I'm writing x here shouldn't be a problem because the scope of this use of x is limited to the function, and it doesn't see that x was used in this polynomial ring earlier. So I can do something like f of 2, and it's going to do 4, and it's not going to get confused about the polynomial ring business from earlier. And this is the notation for defining a function. I should have mentioned that a little bit more specifically. You write the input in whatever symbol you want. I can even do a silly symbol. And then you write whatever operation you want to perform on that input and separate them with an arrow, which is like telling you this input maps to this output. All right, so this is what it looks like when you run Macaulay2 in terminal, and this is going to be similar to what it'll look like in the web interface, which I'll open up a little bit later to show you what that looks like. But I will mention that if you do use Macaulay2 on your computer, it's a good idea to run Macaulay2 in Emacs, which looks a little bit like this. Actually, maybe I should start it from scratch so that you can see what it looks like to start everything from the very beginning.
Actually, ask a silly question. Is there any way to record in?
I'm recording, actually.
Okay, great.
There isn't. I thought about this after I proposed us doing this, but I installed some software that will just record the screen and record my voice. It doesn't record my face, unfortunately, because apparently a video stream can only go to one thing at a time. It can't, like... I was experimenting with this, and like either I would have my little face on the recording, or I would have my face in Discord and not both at the same time. But yeah, not too bad
Okay,
of a.
thanks.
Okay. So I must confess that I don't like Emacs. Emacs is a text editing program that has a very particular design philosophy that doesn't jive with me for whatever reason. However, the people that wrote Macaulay2 have gone through a lot of trouble to make working with Macaulay2 in Emacs a very good experience, and I found that it was better than working in Terminal or working with Macaulay2 in Vim or something like that, or VS Code. There's just not enough support in those text editing programs compared to the support in Emacs. So in Emacs, once you've installed everything, you can open up a Macaulay2 window by hitting F12, and we can do all of the things that I was just doing if we want to. And it even has some nice color coding of things, which makes it easier to tell where everything is, whereas the terminal was completely absent of any colors whatsoever. And one nice thing about Emacs is it makes it easy to open a file where you have some kind of script stored. So when you're working with Macaulay2 for a while, you'll start to notice that you do the same calculations over and over again. You have some ideal that has some special properties that you found it to be a good example. You keep implementing the same ring and implementing the same ideal, and maybe even loading up its resolution or its generic initial ideal, or you do these calculations over and over again, and it gets to be tedious. And the way to streamline that process is to write all the commands into a text file, like this text file right here. And it's just a plain text file that you can edit with anything, although you could edit it with Emacs in particular. And then within the Macaulay2 kernel, you can load this file by just giving the full path to the file on your computer. Oh, whoops, put that in the wrong place. There we go. So I've loaded the whole file, and in particular, what that now means is that R has been given, I guess I already gave R a meaning, so that's not particularly interesting. More interesting is I now has a meaning because it was assigned a meaning in this text file up here. And also, the if we define a function in this text file, I can now use that function within my Macaulay2 session, so I don't need to keep defining functions over and over again. In this file, I've also put a couple of more complicated functions that I defined in some earlier research that I was doing to give you all an example of what you might want to put into a file instead of running over and over again. This function right here does some calculation that is related to trying to find a particular type of resolution of a particular type of ideal. And yeah, you can imagine why you wouldn't want to have to type this over and over again into Macaulay2. It would be very tedious. One thing that I want to point out about this function is we can see this little arrow right here, like how a function was defined in the earlier examples that I talked about up here. However, there's a parentheses here because this is now a function of 2 arguments. So that's how you do functions of 2 arguments. It's an argument of a ring element R and an ideal I. The other thing that I want to mention about this example is that within the function, there's just a whole list of statements, one after the other, just a big sequence of them. And I, at some point, say that the beginning of this ring element is going to be set to 0, and as long as it's 0, keep doing this calculation, and at some point it's assigned some different value. Well, I want my function to return this new value of this variable beg. So I have this return command at the end. I didn't need that back in this more simple function because I didn't have this gigantic list of statements, but when you have a gigantic list of statements, it's a good idea to have a return at the end so that you specify exactly what the output is supposed to be. Since there's so many just temporary variables floating around that you don't want to have outputted.
Excuse me, Michael.
Yeah?
Yeah, is it possible to zoom in?
Oh,
writing is
sure.
too small actually. I'm not.
Yeah.
Yeah, thanks.
And I think I can zoom in here also. Is that better?
Yeah, it's fine now. Thanks.
Did you want me to go back to anything in this document?
No, it's fine. I've been hearing what you're saying. But...
Oh, okay, there. Yeah.
I had one question here.
Yeah?
Am I audible? Yeah.
Yeah, I can hear
I
you.
wanted to ask that if you were to write this in Macaulay directly, can you write something in multiple lines like this? Because from what I saw, that every time you hit enter, it would sort of execute it. So how would one write this function directly in the terminal?
The key is that I have this open parentheses, and that tells Macaulay2 to wait. And in general, if you have any kind of open delimiter, like a quotation mark or something like that, it'll wait until the terminator is provided. So if I were to do something like, say I wanted to find a new function g, and this is going to send an element x to, and then I have this open parentheses. You see how it doesn't evaluate? It's now waiting. And I could also provide some indentation like what I have in this example up here, but it's strictly cosmetic. So I could just do something like, say, print some word, assign x the value x squared, and then have that terminating parentheses, and then now my function's been defined, and I can evaluate 3, and notice that it did this task. So even though there was a semicolon here, which would normally suppress the output of this, since the task itself consisted of printing, it still prints, it still does what I tell it. And then its output only is this last thing. It's only this x cubed. It doesn't, this doesn't contribute to the output. It's just some intermediate task. And that's similar to what happens up here in this more complicated example that I have. This my gens equals flatten entries gens I. This isn't printed. It's not part of the output. It's just some intermediate calculation, but it still does that calculation. I guess another good example of, oh yeah? What were you going to ask?
No, I was just saying that, yeah, understood. Thank you.
The other thing is currently, polynomial ring. Let's see here. Maybe I should have defined this function differently. Like it'll also override, I think this works. I think this will override so currently R is a polynomial ring, but if I evaluate G, oh, it didn't like that. Well, anyway, I was trying to see if it would like reassign the value of R to be a different ring if I put that inside the code for the function, but I'm not going to keep messing with that. The other thing that I wanted to talk about with that's kind of hard to just see by like reading descriptions of the commands is how debugging works. So I'm going to load this little example, not that one, this one. file name, correct? Okay. So this is some little demo that the Macaulay2 language writers put together for how debugging is supposed to work. Actually, I should probably restart the kernel. Actually, I don't think it'll matter. I'll just keep going. Okay, so at any time we can run this command called list user symbols that lists everything that we have defined so far, and it also lists the class of that thing and its current value and where the thing was defined. So it's telling me that these symbols were defined in that document that I loaded earlier, and these symbols were defined by things that I typed in to the running kernel at some point. And we can actually also look at the code for something, which can be helpful when debugging code that you didn't write yourself, but you're using, perhaps from some package or something like that. Notice that this function g has been assigned a value by that demo file that I just loaded. And it makes use of this function f right here, but if I type code f, all that it knows is the function f that I typed in earlier. It doesn't know what this f is from this file. And that's because this f here is some locally defined thing in that file that I don't necessarily have immediate access to. But I can still evaluate g just fine. So I'll evaluate a couple of values. Oh, whoops. And if I evaluate g of 2, I get a division by 0 error. If I zoom out a little bit, you can see that. And it says that I'm now entering the debugger. And now that I'm in the debugger, I can access some local variables, like I can access that function f that I wasn't able to access before. This is outputting the values of all these local variables that were defined inside that other file, that demo1 file that I loaded. And in particular, notice that f is now here, and that it's now defined inside this demo file. It's not the same f that I had before, that I defined myself. And in particular, if I write code f, notice how it now gives me the source code of that mysterious function in that file. And there's this division by the input, 1 over x. And if we look at code g, notice that it evaluates f of y minus 2, so whatever input minus 2. So when I did g of 2, it calculated f of 0, so it divided by 0 right here. So that shows you how to kind of navigate through all of these different files and how to deal with symbols being given different definitions and different scopes. And you can also use the step command to step through the stages of a calculation, like iterations of a loop or different statements in a sequence of statements in some kind of script. It won't let me step forward because it doesn't like this division by 0. But that's how you would do something like if you had an error in a for loop and you weren't sure which iteration of the for loop was causing the error. You could use the step command to slowly step forward through the code until you got the error to occur. And when you're done using the debugger, you can leave it by typing this break command, which makes Macaulay2 resume its normal operational status. And then the last thing I'll do is give a link to more info on using the debugger. Let's see here. I'm going to paste this into the chat. This is available on, I'm going to put it in the office hours chat. This is off the Macaulay2 website, which the documentation for is really great, I have to say. I heard, I think Alexandra mentioned this to me, that the documentation for Macaulay2 used to be quite bad. Didn't you mention this? Like it used to have almost no documentation at all.
Yes, that's correct. But then some graduate students were gradually paid to make it better, so now it's much better.
Yeah. You can find details on pretty much any function. There are also some small tutorials on how to, like I basically took this little demo on the debugger from a little tutorial that I just linked. So lots of good stuff. All right, so the last thing I want to talk about is the web interface. So if I go to the Macaulay2 main page, this is what it looks like, and then there's this try it out button down here. And which one's actually working? I think the server isn't working, and then Macaulay2 web is. Yeah, okay. So there's lots of good stuff here. There's a little interactive tutorial, which is really useful. There's some discussion of Grosvenor bases, lots of good stuff. But, oh, whoops. One thing that I wanted to highlight is that if you go to the editor, this is now going to be operating in a manner somewhat similar to what you saw with the emacs window that I had, where I had like a text document that I was editing and then a running Macaulay2 kernel, and I was able to like take lines from one and test out little bits of some larger script that I'm writing by copying and pasting them. But also I can evaluate the whole thing. I can like run the whole file all at once, which it's not doing for some reason. Why is it not doing it? Maybe I need to load it first? No, that loads a file off my computer. Reset the kernel maybe, and then evaluate?
I think it only runs what you have selected.
Oh. Okay. What did you say, Alexandra?
The window where you're trying to evaluate?
What did you say? Sorry, the
Did
voice
you
cut out from
cursor in the window that you wanted to evaluate?
Did I have my cursor?
On the line?
Yeah, I just had my cursor in some random place, so that's probably why it didn't do what I wanted it to do. But if you are using the editor to create some file of your own, and you want to save it, you can save it to your own computer. And it's just going to save an Macaulay2 file, which you can then upload later with this little upload button in the top right. So this is how you can use the web interface in a way similar to how it works with Emacs, where you can have these script files that you have saved, where you offload a lot of the repetitive work. What else do I want to talk about? I think that's all that I wanted to talk about explicitly. Yeah, there's this tutorial that's really good. That's worth clicking through. It's kind of interactive. Yeah, that's all I wanted to talk about. Are there any questions?
Is there any way to download the results or the input output to a local file so we can access it later? Or like a way to kind of create a table in some way? Say if we
Yeah.
wanted to create a table of all the polynomials.
Yeah, I've done this before, but I don't remember how to do it exactly off the top of my head. What I'll usually do is I'll do like a web search through the documentation website, and then whatever I'm wanting to do.
So Macaulay2 will read and write from file. Read from and write to files. So that's one way to do it.
Yeah, but I just don't remember the syntax for that. Like you can do something like
Oh, nobody does. I look up things all the time.
yeah, but you can be down here and you can maybe you got a list of polynomials from some calculation and they're interesting for some reason, etc., etc. Wait, why did it not like? Oh, because list is reserved name. I can't do that. Maybe I have this list of polynomials, and then I want to. Oh well, I haven't defined these. Okay, I'm not gonna keep messing with this. You have some list. There is a way to just save this as plain text to a file on your computer, and then you can load that, and Macaulay2 will automatically interpret the plain text in an appropriate manner based on the current assignment of values of variables in your running session. So if I save this list as a plain text file, it's just going to be some file that has this potentially enormous list in it. And it has X's and Y's and things like that. And then I later on load up a ring in a session that is, the integers adjoin X, Y, and Z. And then I load this list, it will intelligently be like, oh, this is the list of polynomials in X, Y, and Z. And you'll be able to interact with these in a manner that you would expect. It won't like do something weird where it doesn't know what X is or something like that. But I don't know how to
So
do that.
the command for that would be toString. If you did
Ah,
toString of your list, it would just produce this plain text version that you can really paste into a text file and use later if you wanted to.
yeah,
Of course, this one doesn't change much, but if you were to have actual polynomials, you will see that when you take toString, it'll include the multiplication sign, which is needed for the input but is suppressed in output.
yeah. So if I type my list, print my list. Oh, it's not doing it. Maybe my list.
Oh, yeah.
And then 1.
I think I found it. There's also toExternal string, which allows you to convert it into something that you can read back later.
Huh, why is it doing this? Anyway, yeah, that's how to do it. You can save the data that you have gotten from some large calculation. If you want to save an entire session, like you want to record every single input that you made and every single output, I'm not sure if there's a way to do that natively within Macaulay2, but I did do some experimentation at one point with this thing called Jupyter notebooks, which is really popular for Python programming and data science. And it is like a way to take any programming language and make it behave somewhat like Mathematica, if you've ever used that software. But it like has computational cells, and you can save the whole notebook as a file. And that wasn't too difficult to set up. If you're interested in something like that, I could help you get that set up and hook you up with some links and resources for how to do something like that. If you already use Jupyter and you like how it works or something.
Yeah, Jupyter's pretty nice. Yeah, thank you.
So maybe I'll put that into the chat. There's like a package that somebody made called Macaulay2 Jupyter or something, and then you have to install that, but then it works fairly easily. I didn't have to spend too much time hacking it together.
I should say Macaulay2 also works under Sage, which you know, has a notebook-like web interface. So if you prefer that, that's fine.
Isn't there, this CoCalc thing? Is that like that? Or no, Sage Math Cell, this is what it is.
CoCalc is the same, yeah. Right.
So, could I do that here?
So you can somehow run Macaulay2 under CoCalc. I think so. It seems to recognize it's Macaulay2.
Oh, but I guess this isn't like a real notebook. Because it's like a notebook, but only one input and output entry, and it's like formatted. I can't copy and paste all of this or something. So maybe this isn't. Maybe this is the right way. Do it through CoCalc. I don't know. I've never used this before. Is Sage and Macaulay2, is it just like you install Sage on your computer and then Macaulay2 is in there? Is that how it works?
Well, you can do it in a browser. So the very last thing on the page you're sharing, I think the Sage Math Cell is some form of Sage that understands Macaulay2. But I've never actually, so it's probably not worth exploring right now. It's just maybe one important additional thing to tell you is that, you know, we can give you templates for whatever you need, right? All the calculations that you need, we can get you started with some sample code, and then you can modify it from there. That's the easiest way to get started with this. Of course, you should read the written Macaulay2 tutorial that Michael prepared to see what sample code is available in there. But if you need more sample code, then we'll try to provide some more for you. So you don't have to feel like you need to know a lot of specifics about Macaulay2, a lot of syntax and so on. We can give you some of that syntax, and then you will learn more as you experiment with it.
Yeah. There's a lot of syntax in the tutorial already, but if you also just don't know how to do something and don't even like know how to ask for the thing that you want to do, like don't know the right word for it or something like that, so it's difficult to search for it. I've been in this situation a lot myself. You can feel free to ask us about it, and we probably can point you in the right direction or can find the right thing for you or something like that. Any other questions?
Anything that anyone wanted to do in Macaulay2 and you couldn't for whatever reason? Now's the time to ask how to do that.
Maybe since we're here, I'll mention one more thing about Macaulay2 that maybe I wish that I'd known. I mentioned that Macaulay2 is everything has a type. And in some situations, you may want to create a function that does different things for different types of input. So like maybe you write a script that works on an ideal and then, or write a function that works on an ideal, and then you also want it to be able to work on a list of polynomials. You just want it to like run the function on the ideal generated by that list of polynomials or something like that, or maybe vice versa. You can do something like that by using something called methods. So you could say like define a new method, and there are some options that can go in here, but for the basic functionality, all you need to do is say that this is, oh wait, not a method, is a method with no, yeah, okay. You just need to say that it's going to be some method, and then you can install a particular function for particular types of input, and this is what this code was back here. I installed some method that did a specific thing to, in particular, a ring element and an ideal, and if I tried to run this code on something that wasn't a ring element and an ideal, it would check the type and complain that it's not. It would say, I don't know what to do with what you handed me. I only know what to do with a ring element and an ideal. I'm not sure if any of us will need to do that, but good to know that it exists in case you find yourself needing to. Like when I first started writing Macaulay2 and I needed to do something like this, I tried a big if then statement, like if you're a ring element, do this. If you're an ideal, do that. And that's too cumbersome. This automates that for you. All right, well, if there aren't any other questions, then maybe we should call it a day, and I'll go get some breakfast.
Thank you very much, Michael. Last call for questions. All right. Well, surely there will be many
Thank you.
questions as we progress. But yeah, go ahead.
Oh, Alexandra, somebody just said thank you, and then I waved to them because I thought that they were
I
leaving.
see. Okay, well, I was going to say surely there will be many more questions, but you know, feel free to ask in Discord when you get stuck, and we'll make sure to get you unstuck as needed.
Yeah, I might create a video at some point on where I install Macaulay2 on my computer to show what that looks like. But if you want to install it yourself and you get stuck on something or get weird error messages, I'd be happy to help walk you through that as well. But the web interface is also very good and should be fine for most purposes.
Thank you.
Thank you.
Thank you. Have a great day.
You too.
Thank you.
Thanks.
See y'all later.
Hi, everybody.